These examples go in section 7.5, the dot product. Example 1, given vector v is equal to -2, +6, and vector w is equal to -3, -1, find part A, v dot w, part B, w dot v, part C, v dot v, and part D, the magnitude of v. All right, let's look at part A. The dot product of v dot w is going to be a scalar multiple. And what we're going to do is we're going to take the first coordinate -2 and we're going to multiply it by the first coordinate of vector w, -3. And we're going to add that to the second coordinate of v, that's 6, multiplied by the second coordinate of w, that's -1. -2 times -3 is going to give me +6. 6 times -1 is going to give me -6. And when I add those together, I get 0. Part B, w times v, we're going to take the first coordinate in w, this is -3, and multiply it by the first coordinate in v, which is -2. And then we're going to add it to the second coordinate in w, which is -1, and we're going to multiply that by the second coordinate in v, which is +6. -3 times -2 is going to give me +6. -1 times 6 is going to give me -6, and 6 plus -6 is going to give me 0. And so what this right here tells me is that our dot product is commutative. It doesn't matter if we do v times w or if we do w times v, we're going to get the same answer here. Okay, part C, what happens when we dot a vector with itself? All right, that's going to be the first coordinate of v, -2, times the first coordinate of v, which is -2, plus the second coordinate of v, which is +6, times the second coordinate of v, which is also +6. This is going to give me +4 plus 36, and that gives me 40. And then finally, the magnitude of v, remember, this is just going to be the square root of the first coordinate squared plus the second coordinate squared. This is going to give me the square root of 40. This is the same thing as 4 times 10. And the square root of 4, y'all, is 2, but 10 does not have a nice square root, so that stays underneath. And so the magnitude of v is 2 times the square root of 10. Example 2, find the angle between the vector v, +5, -1, and vector w, -5, +12, round to the nearest tenth of a degree. All right, in order to find the angle in between, first of all, we need to know the dot product of v times w. This is going to be 5 times -5, using their first coordinates, plus -1 times 12, using the second coordinates. This gives me -25 plus -12, and when I add those together, that's going to give me -37. Now I need the magnitude of vectors v and w. The magnitude of vector v is going to be the square root of 5 squared plus -1 squared. This is going to give me the square root of 26, and that won't break down. The magnitude of w is going to be the square root of -5 squared plus 12 squared. This is going to give me the square root of 169. That does have a nice square root, which is 13. And so when I want to find the angle in between the vectors, remember I'm going to use the cosine. So the cosine of my angle is the magnitude, -37, divided by 13 times the square root of 26. Well, if the cosine is equal to that ratio, it must be true that the angle is equal to the inverse cosine of that ratio. And I'm going to put that in my handy dandy calculator. And this gives me 123.9 degrees. Example 3, determine if the given vectors are orthogonal. Part A, vector v 4i plus 3j, and w 6i minus 10j. All right, to check and see if we have orthogonal, we need to know if the dot product is equal to 0. So for part A, we're going to look at the dot product of v times w. That means we're going to take 4 and we're going to multiply it by 6. And we're going to add that to 3 times negative 10, and that's just using, again, the first coordinates and then the second coordinates here. This is going to give me 24 plus negative 30, and that's going to give me negative 6. So since this product is not 0, these are not orthogonal. Let's look at part B. Vector S, negative 2i plus j, vector t, 11i plus 22j. We're looking for the dot product S dot t. Negative 2 times 11 plus 1, because there's an understood 1 coefficient right there, times 22. And again, this is first coordinates and second coordinates. We got negative 22 plus 22. That does give me 0. So since this product is 0, yes, these are orthogonal. Example 4, given the vector v is equal to positive 7, negative 3, and vector w is equal to negative 2, negative 6, find the projected vector w on v. Okay, back here in our formulas, our projected vector right here, we need to find the dot product between v and w. We're going to divide that by the magnitude of w squared, and then this is going to give me a scalar. And whatever that number happens to be, I'm going to multiply it by the vector w. So I'm using the vector w in 3 places here. Okay. So let's start off with the dot product of v times w. This is going to be 7 times negative 2 plus negative 3 times negative 6. I get negative 14 plus 18. This is going to give me 4. All right. So now I've found my dot product. Now I want to find the magnitude of w, and whatever I get, I want to square it. The magnitude of w squared is going to be the square root of negative 2 squared plus negative 6 squared squared. This is going to give me the square root of, let's see, we're going to have 4 plus 36, this is going to be 40 squared, and now that radical and the square will cancel, so the magnitude of w squared is going to be 40. And so the projected vector of w on v is going to be v dot w divided by the magnitude of w squared times vector w, which is negative 2, negative 6. Now this fraction right here is actually going to reduce to 1 over 10, so I really have 1 over 10 times the vector negative 2, negative 6. This is going to give me negative 2 over 10, negative 6 over 10, but these fractions will reduce. They do, in fact, reduce to negative 1/5 and negative 3/5. And that is part A. Part B, find vectors v1 and v2 such that v1 is parallel to w, v2 is orthogonal to w, and v1 plus v2 is equal to v. Now, conveniently, we've already found v1. It's right here. So let's go over to the next slide. We'll bring our v1 with us and our v, because we know we want v1 plus v2 to be equal to v. All right, here's our v1 we just found. Here's the vector v that was given to me, and this property right here has to be satisfied. Well, if v1 plus v2 is equal to v, and I know this one, it's right here, and I know this one, it's right here. If I'm trying to solve for this, if we subtract the v1 to the other side, we could say that vector 2, or v2, is equal to vector v minus vector v1. I know that looks like a y there, so I'm going to take off that little tail. There we go. Okay, so let's find v2. Vector v is positive 7, negative 3, and we are supposed to subtract negative 1/5, negative 3/5. This is vector v1. All right, this vector is 7 minus negative 1/5 and negative 3 minus negative 3/5. 7 minus negative 1/5, this is 7 plus 1/5. This is going to give me 7 and 1/5. Or we could write this as 36 over 5. And then negative 3 minus negative 3/5. So this is negative 3 plus 3/5. Okay, this is going to give me, let's see, negative 2 and 2/5. But if we change it into its improper form, it looks like it's going to be negative 12 over 5. All right, so we were supposed to find v1 and v2. Right here's v1, and then on the next page, we just found v2.